So let's think back to what we did back when we were doing exponential graphs, back when we were doing parent functions. If you had something like this, x squared, what did the graph of that look like? That's the touchdown, okay? What was this? It was the same shape, but what happened to it? It moved four to the right. What was backwards about this? Remember, the negative goes to the right, the positive goes to the left. And then what happened here? What was that? That moved it up to. So same thing happens with trig graphs, okay? So this is going to move the sine function where? Not down, to the right. How far? Pi over 2, okay? So this is going to move the sine function to the right, pi over 2. If you had, so this is going to move to the right. And if you had the sine of x plus pi over 2, that moves it where? To the left, okay? So the way you can look at it is, look in the parentheses. What would make this equal to 0 when x is equal to what? What makes this equal to 0? X minus pi over 2 when x is equal to, it was not a trick question, but x minus pi over 2. What does x have to be for that to be 0? Pi over 2. So the phase shift is just pi over 2. It's a positive number, moves to the right. What makes this equal to 0 when x is what? Negative pi over 2. That's moving to the left, okay? So you can think of it in that way. So now what we should be able to do, we should be able to look at, and this is our final bell or whistle that we're adding to our trig graphs. We should be able to look at functions that look just like this and be able to graph them. So I'm just going to fill out the left side because, well, no, that's a plus over there. So sine or cosine, what is the amplitude in this? And there should be an A right there in front of that. So the amplitude is just, it's the absolute value of A. How do I find the period? Yeah, it's 2 pi divided by B, okay? Which of those is my vertical shift? K. K is my vertical shift, okay? In this case, if I've got H being a positive number, X minus H, this moves me where? Minus moves me to the what? To the right. So the phase shift is H to the right, okay? That tells me how far this graph moves to the right. And then the same thing over here. This is the amplitude. The period is still 2 pi over B. The vertical shift is K, but this one, X plus H, that moves me H to the what? Yeah, H to the left, okay? Yes. That's just our formula. So 2 pi divided by B is always the period, whatever this number is in front of the variable, okay? So let's look at some real examples here and go from there. So look at this one. What is the amplitude? 3. How do I find the period? Yeah, so it's 2 pi over 3, and the 3 that I'm looking at to get that is right there. So it's 2 pi over B, okay? What's the vertical shift? Yeah, you can, it's either +1 or it's up 1, either way, okay? And now the left or right, we call that a phase shift. How does this one move? Yeah, pi over 2 to the right. So it's pi over 2 to the right. Okay. What about the next one? What's the amplitude? Yeah, it is 5. What is the period? Yeah, it's 2 pi divided by 2, which is what? Pi. Vertical shift. Yeah, so it's +7, or that is the direction of up, okay? And then what is the phase shift here? Yeah, so you can either write it, it's negative pi over 4, or pi over 4 to the left, okay? Amplitude of the next guy. Okay, this one's a little bit tricky with the period, though. Let's go ahead and write amplitude, okay? Now, our form, it always has to be what A sine of B x plus or minus h plus k. That b needs to be factored out, okay? So what I have to see here, this is a little bit different. See, before I've always had the 2 outside the parentheses here. It's been factored out. I have to factor this 4 out. So I've got to rewrite this as 3 sine factor out of 4. Okay. What do I multiply 4 by to get 4x? X. Okay. What do I multiply 4 by to get pi? Pi over 4. Okay. Okay, so if you check your work, this is 4x, that's 4x. What's 4 times pi divided by 4? No, 4 times pi divided by 4 is pi, which is that, okay? So I had to factor out a 4 in order to get this in the form that I needed. So now it's in this form, a sine b x plus h plus k. So the amplitude is 3. What's the period? It's 2 pi divided by what? 4, which is pi over 2. And what is the vertical shift? Yeah, it goes up 2. And then the phase shift is what? Left. So it can be written as negative pi over 4, or you can write it as pi over 4 to the left. Either way. Those mean the same thing. Well, when you factor 4, if I factor a 4 out of this expression, so I've got 4x plus pi. If I'm going to factor a 4 out, then I have to ask myself, what do I multiply 4 by to get 4x? X, okay? What do I multiply 4 by to get pi? So that's pi over 4. That's the only thing that it can be. So that's pi over 4. And then you check yourself, 4x and then 4 pi over 4. So then it becomes 4x plus pi. So you're factoring the 4 out for that. There aren't going to be many that are like that, but you just need to know that when it doesn't appear in this number that's in front has to be, you got to have a number in front of the parentheses, okay? I got to do the same thing here. So this is f of x equal negative cosine. Let's factor out the 1/2. What do I multiply 1/2 by to get 1/2 x? X, okay. What do I multiply 1/2 by to get 4 pi? Yeah, half of 8 pi is what? Excuse me, half of what? I said it wrong, so it'll back up. What I was looking at when I was. What do I multiply 1/2 by to get 2 pi? Yeah, it's 4. 2 is half of 4, so this is 4 pi minus 1/2. And then check your work. This is 1/2 x. What is 1/2 of 4? 2. So this is 2 pi. Okay. So it's factoring, but it's got a little bit of a twist on it. So now look at this. What is the amplitude? Amplitude is 1. What is the period? Yeah, 2 pi divided by 1/2, which is just 4 pi. Vertical shift. It goes down by 1/2, and the phase shift. Yeah, 4 pi to the left. Okay. There's one other thing about this graph that I didn't ask, but what is it? One more property of this graph. This last one. There's one more thing to describe what happened to this graph that didn't happen. I didn't do it to the other ones, but what does the negative tell you? It's been reflected about the x-axis. So when you go to graphing, you've got to catch that part as well. So I feel like when we get to this section, like the first day we graphed sine and cosine. We had amplitude and we had reflections. And then the next day we talked about the period. The next day we talked about vertical shifts. It's sort of like, you're stacking, you're building a house out of playing cards. And by the time we get, we've been fine. Every day I put one card on it. When I get to this last day, this is like the 5th card. It's not that hard, but now you've got several things to worry about. You got 5 or 6 different things when you look at this that you have to take care of. So you got to make sure you pay attention in today's lesson because, like I said, in and of itself, it's not that hard, but we've started to add several things together. So when you graph this, you've got 5 or 6 things you've got to work through mentally before you graph this. So let's talk about how we do this. We need to graph this particular function. What is the amplitude? 1. What is the period? What number do you see in front of that x? The period. Okay, guys, this is, I'm looking for it to be, it needs to be in this form. A sine b x plus or minus h plus or minus k, something like that, okay? So b is the number that is in front of the parentheses. What number is in front of that parentheses? 1. So the period is 2 pi over 1. What is that number? 2 pi. Well, you have to look and see, this needs to look like an x, okay? If this was a 2x, I got to factor a 2. If it was 2 on the outside of the parentheses, I'm good, okay? So what's the vertical shift here? 1. So it goes up by 1. And then the phase shift is what? Yeah. So it's negative pi over 4, or another way of writing that is pi over 4 to the left. Okay? So now I need to be able to graph this. Okay? So let's put together what we need to do to graph this. So if I look at right here, this is 0. Count out how many spaces? 1. How many do I always count out? How many do I always count out? Let's go with 4. 1, 2, 3, 4. And I'm going to call that point what? 2 pi. That's how I'm going to get one period of the graph, okay, from 0 to 2 pi. That makes this point right here what? Pi over 2. And then what is this one here? Pi over 4. So this is 0, 1/4, 2/4, and this is 3/4 pi. So what about the vertical shift? Where is that? At 1. So if I go up 1, and I'm going to draw a horizontal line just like I always did, okay, that's where I'm going to be doing my graph, okay? But now the phase shift tells me this curve has moved where? To the left, how far? Yeah, so instead of starting at 0, it's going to start at negative pi over 4. Let me write that a little bit better. So what's going to happen here is my graph is going to start right here. And instead of ending at 2 pi, it's going to end where? Yeah. So I'm going to graph in between there and there, okay? So all I did before I even do my graph, it moved up 1, that was the vertical shift. Everything moved pi over 4 to the left. So instead of starting at 0, I'm going to start right here. And now I'm going to graph the sine function just like I always do it, okay? Sine function starts where? 0. It ends at what? Halfway in between is, okay? And then it goes up to where? Halfway between these 2 points, it goes where? Up to 1. The amplitude is 1, so it's still the same. And then it goes down to negative 1, okay? So this is what the function does. So this is 0, 1, and 2. Okay. So this is very similar to the vertical shift, but instead of drawing one line that goes up or down, that phase shift is going to take my period and it's either going to move it to the left or right. So I draw these boundary lines to say, now this is the way this graph looks. Okay. Now this feels a little bit more complicated, right? It's just one more thing added on, but like I said, the weight of this one feels a little bit heavier when people see this. So you need to spend some time with these guys to see what happens. Okay, let's graph the sine of 2x minus pi over 4. Okay, what is the amplitude here? Nope. Amplitude is 1. The period is 2 pi divided by what? 2 pi divided by 2, which is pi. Okay. Vertical shift. No vertical shift. Okay, good news. It's one less thing to do. Phase shift. It shifts where? Yeah, pi over 4 to the right. So it shifts pi over 4 to the right. Is it reflected about the x-axis? No. Okay. So now I have enough information that I can graph this guy. So if I come here, this is 0. And I'm just going to spread things out a little bit. So I'm going to count by 2. I'm going to count 1, 2, 3, 4. Okay. Just going to count it that way and label this what? Pi. Then this is pi over 2. This is pi over 4. So that's 1/4, 2/4. What is this? 3/4 pi. Okay. So I just spread things out a little bit here. So every other line, just to make the graph look a bit better. So vertical shift, there's no vertical shift. So that means I'm going to be graphing right here. Okay. On the x-axis. Okay. That's where I'm going to do my graph. Now this shift of pi over 4 in what direction? To the right. Okay. So that means instead of starting here, where am I going to start? Yeah, I'm going to start right here. And instead of ending right here, I'm going to end right here. Okay. This is 4 over 4 pi, right? What's 4 over 4 plus 1 over 4? Yeah, 5/4 pi, which is right there. So I'm going to graph this from here to here. Okay. So this is where you need to know the definition of your sine function. Sine function starts where? 0. Ends where? Halfway in between is 0. Sine function goes up to what number? 1. Okay, and this amplitude is 1, so that's where it goes. So it goes up to 1, and it goes down to -1. And then it's the same function you keep graphing over and over. So the graphs are all looking the same, it's just that they're moving left and right, moving up and down. Okay? So this is one complete cycle of the sine function, starting at pi over 4, ending at 5 pi over 4. Okay? Sure. Okay, looking at this one, cosine function. What is the period, excuse me, what is the amplitude? Amplitude is 1. What is the period? It's 2 pi over what number is right in front of the parentheses? 1. So it's 2 pi. Okay. Vertical shift. Yeah. Of +1. So its vertical shift is up 1. Okay. Phase shift is pi over 2 to what direction? Pi over 2 to the right. Has it been reflected? No. Okay. So let's graph this guy. This is 0. And let's see. I can count out by 2s. Just so I spread, it doesn't matter. You can count 1, 2, 3, 4. Okay. It's probably easier with your pencil. But on this board, I'm just going to count 1, 2, 3, 4. I'm going to space it out a little bit. There's nothing wrong with you counting each one as 1. If I do it this way, this is 2 pi, just gives me more room to write. This is pi, and then this is pi over 2, and this is 3/2 pi. Okay. And now the vertical shift is what? Up 1. So if I go up 1, I'm going to draw a line right there. Okay, so that's where my new axis is for graphing this. Now, moving it pi over 2 to which direction? Right. So instead of starting my graph at 0, where am I going to start it? Pi over 2. So I'm going to draw a line here. Okay. So that means instead of ending it here, this is what? 2 is, it's what, 4 over 2, right? 4/2. Okay. So this is 4/2 pi. What happens when I add another 1/2 to 4/2? What do I get? 5/2. So right here is going to be 5/2 pi. Okay. So this is a sine function. Sine function starts where? Excuse me. This is a cosine function. Cosine function starts where? Starts at 1, and the amplitude here is 1. Okay. Cosine function ends where? 1. Halfway in between, it is where? -1. Halfway between the first 2 points is 0, and halfway between the second 2 points is 0. So you see this. Okay. Okay. So what's the challenge with this, guys? What is, huh? Yeah. So, like I said, don't get stressed out about I counted every other one. You can count every one. It's just, I just like to spread it out here on the board so it's easier for you to see. Okay. The other thing is, like, when this phase shift is pi over 2, think of this instead of 2 pi, well, that's 4/2. Okay. So 4/2 plus 1/2 is 5/2. So we got several things going on this one. Okay. What is the amplitude? Amplitude is 2. What is the period? It is 2 pi divided by what? 2 pi divided by 2, which is pi. Vertical shift. Yeah, down 1. Phase shift. Pi over 4 to the left. Okay, so this is pi over 4 to the left. Has it been reflected about the x-axis? Yes. Okay, so this has like every bell or whistle on this guy. Okay, so in order to graph this guy, I'm going to start here at 0. Like I said, you can count 1, 2, 3, 4, counting every line because it's easier with your precision of your pencil. I'm going to count every other line just so it spreads out easier for my graph. Okay, so I count 1, 2, 3, 4, and what do I call that point? Pi. Okay, if that's pi, what is halfway between there and 0? That's pi over 2, right? What is half of pi over 2? Pi over 4. So it looks like this is 1/4, 2/4. What is this one? This is 3/4 pi. Okay. So normally I would graph from 0 to pi and I would have a complete cycle. But this one has moved where? Pi over 4 to the what? Left. So if I come over here, this is minus pi over 4. Okay. So where's my vertical shift? My vertical shift is what? Down 1. So let's draw this. Okay. And instead of graphing from 0 to pi, I'm going to start my graph where? At negative pi over 4. And instead of ending it at pi, it's going to end where? At 3/4 pi. So this graph starts right here. Okay. So this is a sine function. Sine starts at what? 0. It ends at what? Halfway in between. Here, okay? And then the sine function goes what? It normally goes what? Up 1. What happens when the up 1 gets multiplied by a negative 2? Where's it going to go? Up or down? It's going to go down, okay? So normally it goes up to 1, but when that's multiplied by negative 2, I'm going to go down 2 right here. Normally, the sine function would be at negative 1 here. What happens when a negative 1 is multiplied by a negative 2? It goes up 2. So right there. Okay. And that is your graph. Okay. Negative 2 sine 2 x plus pi over 4 minus 1. Okay. How many more? One more, and then you can turn loose on the homework and take a look at it. So seriously, I mean, this feels a lot harder, or okay. It's just like I said, it's one more thing that's added, but the weight of it just feels heavier because it's a little bit more you have to do with your graph. Okay. So tell me about this one. What's the amplitude? 1. What is the period? Nope. Period is always 2 pi divided by the b. So it's 2 pi divided by what? 2 pi divided by 1/2, which is what? 4 pi. There we go. Vertical shift. It goes up 3. The phase shift. Pi to the, pi to the right. And the reflection. Has it been reflected? Yes. Okay. Okay, so to graph this is 0. So I'm going to space mine out just a little bit again. Like I said, if that's stressing you out, just stick to what you always know. 1, 2, 3, 4. Count it like that. It's just easier for me up here to space them out. So I'm going to count 1, 2, 3, 4. What am I going to call that point? Yeah, that is 4 pi. This is a nice one because if that's 4 pi, this is 2 pi. This is pi. This is 3 pi. And my shift is what? Now my vertical shift is what? Up 3. So 1, 2, 3. So that means this is a line about which I will graph. Okay. Now, instead of graphing at 0, my whole thing has been shifted where? To the right by pi. So that means instead of starting at 0, where do I start? Pi. Okay. Instead of ending at 4 pi, I'm going to end at what? 5 pi. Everything gets shifted to the right pi. So normally I would want to graph this from 0 to 4 pi. We just shifted everything to the right by 1. And so now what you look at where you drew this, and this, my graph starts here and ends here. This is a cosine function, okay? Cosine starts at where? 1. But what happens when the 1 gets multiplied with a negative? It's going to start at negative 1, okay? If it starts at negative 1, where does it end? Yeah, all of these graphs, if you're graphing one cycle or one period, it has to start and end at the same place, okay? Normally the cosine halfway in between is at negative 1. What happens when the negative 1 is multiplied by a negative? Yeah, it's going to go up to positive 1. And then the easy ones, halfway between these 2 points, I'm at what? 0. Halfway between these two, I'm at 0. So I keep saying 0, but technically I'm not at 0, I'm at 3 because this thing got moved up by 3. But I just pretend like this is my new axis. And then it's just a matter of connecting the dots at this point. Okay? So that is our graph. Negative cosine 1/2 x minus pi plus 3. Okay? So, just to summarize, this is all we're going to do in terms of graphing. Okay? What we'll do tomorrow is writing equations, but this is it. So, we started out just graphing sine and cosine, but now you should be able to look at A cosine B, x plus or minus h plus k. So A tells you the amplitude. 2 pi over B is the period. H is going to move it left or right. K is going to move it up or down. Okay, and that should be it.